Hi everyone, in this lesson 9.5 we're going to be talking about dilations. It's our fourth type of transformation that we've been talking about here in chapter 9. There's a very detailed formal book definition. I'll let you read that on your own. It's probably just going to give you a headache, so if you don't want to read it, you don't have to. Here's the not so confusing definition, putting it more in layman's terms, more in terms that we can understand. What a dilation is it is a transformation. It's using a center point and a scale factor that may change the size and the location of a figure. So a dilation is where we have that center point. The scale factor is what we multiply by to make a figure larger, smaller, or it could remain the same size. And I'll show you that right now. So here we have our center point, as you can see that where it says center right there. We have triangle ABC and the dilation for the image A prime, B prime, C prime. The distance from the center to point B, for example, is 3.89 centimeters. The distance from the center to B prime is 7.49 centimeters. And the scale factor right now is 1.93. Now I'm just going to make the scale factor to be 2. It's going to be 2 on the nose. There we go. When it's 2 on the nose, our image, A prime, B prime, C prime, is twice as big as my preimage triangle ABC. And you'll notice the distance from center to B is 3.89. If we double that, we get to 7.78. Okay? So the distance from the center to the image and the distance from the center to the preimage is very much related to the scale factor. If the scale factor is 3, it's 3 times bigger. Triangle A prime, B prime, C prime is 3 times the size of triangle ABC. And that's what a dilation is. Notice when my image is the same size as my preimage, right there, we have a scale factor of 1. That's an isometry. That's an isometric, a congruent transformation. Okay? And as you can see, the distance 3.89 from center to B and center to B prime. And then if my image is smaller than my preimage, let's say a scale factor of 1/2, for example, 0.5 right there. Now my image, A prime, B prime, C prime, is half the size of triangle ABC. So that's how a dilation works. When the scale factor is bigger than 1, it's an enlargement. The image is larger than the preimage. When the scale factor is less than 1, all of these scale factors are less than 1 right here. We have a reduction. The image is smaller than the preimage. And when the scale factor is exactly 1, then it is isometry. It's a congruent transformation. So that's what we learned here with that slide that we just did. So when the scale factor is greater than 1, scale factor is sometimes referred to the letter R, and other times it's referred to the letter K. So when the scale factor R or K is greater than 1, we call that an enlargement. And the image is farther from the center, further away. If the scale factor is equal to 1, we call that isometry. It's the exact same size, so it's equidistant, or the same distance away from the center. And then if the scale factor is less than 1, that's when the figure got smaller. We call that a reduction. The dilation is a reduction, and the image is closer to the center. It is closer to the center. All right, one more thing that we're going to look at here with scale factor. We can have a negative scale factor. We don't see it quite as often, but right here, we see that the scale factor is a negative 2.39. Let's make it a negative 2. So when it's a negative 2, my image is twice as big as my preimage. Triangle A prime, B prime, C prime is twice as big as triangle ABC. The distance from A to the center and A prime to the center is twice as long. The reason why it is a negative scale factor, to put it in terms that you'd understand, I guess, is the image points are on the other side of the center as the preimage points. When they were positive scale factors, all the points were on the same side of the center. Now B is on the other side of the center to get to B prime. C is on the other point of the center to get to C prime, and A prime. So that's when we have a negative scale factor. So what did we learn with this? If the scale factor R or K, if it's positive, then the image is on the same side of the center as the preimage. That was like the first slide that we just did. And now this side, this last slide that we just did, if it is a negative scale factor, then the image is on the opposite side of the center as the preimage. All right, let's get into some example problems. We're going to skip this one and do that one in class tomorrow. If I want to find the image when I'm given the preimage, I could simply multiply by the scale factor. Okay? If I want to find the preimage when I'm given the image, let's see, I want to make sure I'm saying this right. If I want to find the preimage when I'm given the image, I'm just going to divide by the scale factor. So if you're given like the actual letters, A, B, C, and we want to find the image, A prime, B prime, C prime, if that's the case, we want to multiply by the scale factor. That's what this is saying. For every x coordinate, you multiply by the scale factor. For every y coordinate, you multiply by the scale factor. K and R, again, are both letters used to symbolize scale factor. If we are given the image, if we're given the prime letters, if we're given A prime or B prime or C prime, and I want to get to the preimage, I got to divide by the scale factor. So take my x coordinates and divide it by the scale factor k. Take my y coordinates and divide it by the scale factor k. That's when it's centered at the origin, by the way, when it's centered at the origin. So here I have one. The origin right here is my center, and I have triangle RJC. CJR. Let's put CJR in our graph. If we go left 1 up 2 and right 3 down 2 and then right 4 up 5. Here's our triangle. And what I want to do here is I want to find the image. So I want to find C prime, J prime, R prime after a dilation centered at the origin with a scale factor of 3. So if C is at -1, 2, J is at 3, -2, and R is at 4, 5, to find C prime, J prime, and R prime, if I want to find the image, I simply multiply by the scale factor. The scale factor is 3. So each of these points, I'm going to multiply all of them by 3. A -1 times 3 is a -3. 2 times 3 is 6. So C prime is at left 3, up 6. Right there, there is C prime. J prime, 3 times 3 is 9. A -2 times 3 is a -6. So J prime is at right 9 down 6. Right there. And R prime, I multiply by the scale factor of 3. 4 times 3 is 12. 5 times 3 is 15. R prime is at 12, 15. Right up here. So now when I make triangle C prime, J prime, R prime, it has been dilated. It's 3 times bigger than triangle CJR. It's an enlargement because the scale factor is bigger than 1. The scale factor is 3. It's 3 times larger. Notice again how the origin is the center. And so this distance from the center to C and the center to C prime, they're on the same line or the same ray if this ray were to continue on. But C prime is 3 times further away. Here's R and R prime. They're going to be on the same ray. Here's J and here's J prime. each prime letter is 3 times further away from the origin as its preimage is. All right, so if we were to ask you to find the scale factor, how would you go about doing that? The scale factor is the image length divided by the preimage length. Sometimes people refer to it as the end over the start. Or again, sometimes people say it's the prime letters, because that's the image, the prime over the actual letters. So let's take a look at this one right here. What is the scale factor? I would just want to find 2 corresponding sides, like EF and E prime F prime. Okay? I could easily count the distance, and segment EF is 2 units long. Segment E prime F prime is 1, 2, 3, 4 units long. So you put the prime letters over the actual letters. Or the end, the image, is 4 divided by the start, the preimage, is 2. So my scale factor, some people call it K, some people call it R, whatever it is, the scale factor is 2. And we know that that's an enlargement. Notice how my image got bigger. The red quadrilateral is bigger than the blue quadrilateral. It enlarged because the scale factor is bigger than 1. The scale factor is 2. This one is really the same thing, but I want to show you when it's centered at the origin. Notice how I could pick any of these points if I wanted to. I'll just pick point F. Point F is at right 1, down 2. Notice where F prime is. F prime is at right 2, down 1, 2, 3, 4. Right 2, down 4. So in a previous example, I said to get from my preimage to my image, I multiply by the scale factor. So if I have my preimage 1 multiplied by what number gets me my image of 2? This number right here is the scale factor, right? 1 times the scale factor gives the image. So if I were to divide both sides by 1, of course my scale factor is 2. I can do the same thing for my y-coordinate. A negative 2 multiplied by what number, we call that the scale factor, gives the image of a negative 4. Well, I simply divide both sides by a negative 2, and I get k to equal a negative 4 divided by negative 2 is a positive 2. So once again, I get my scale factor equaling a positive 2. This is the same it's the same figure as the last slide, so we should get the same scale factor. But I wanted to show you how you could use it with the dilation at the origin as well. Okay, the last thing we're going to finish up with here. So if we have a dilation, again, centered at the origin, that's a big deal right there, because when it's centered at the origin, we just multiply or divide by the scale factor to get the answer. It has a scale factor of 0.5, so it's going to be a reduction because my scale factor is less than 1. It's applied to triangle with vertices D, E, and F. What are the coordinates of the dilated points? So if I have D, E, and F, that's my preimage. So I'm just going to write that right over here. 4, 5 is point D. Point E is 4, 9. And point F is at 4, 7. If I want to find my image, I simply multiply by the scale factor. I'm simply going to multiply by k. Okay? So each and every one of these points, I simply multiply by 0.5. So 4 times 0.5 is 2. So D prime is at 2, and 5 times 0.5 is 2.5, or 2.5, or 5 halves. E prime, I multiply 4 times 0.5 and get 2. I multiply 9 times 0.5 and I get 9 halves, or 4.5. There's E prime and F prime. I simply multiply by the scale factor of 0.5. 4 times 0.5 is 2. And 7 times 0.5 is 7 halves, or 3.5. 3.5. All right, last one for the day. This time, again, I have a dilation center at the origin. It has a scale factor of 2. So my scale factor of 2, it's going to be an enlargement. But this time I am given the image. I'm given D prime, E prime, and F prime. So if I'm given the image of a negative 6, 4, that's point D prime. E prime is at 2, negative 3. And F prime is at 4, 6. To get to my preimage, to go this way, I'm going to divide by the scale factor. So I'm going to divide by K, or I'm going to divide by 2. And that's how I will get D, E, and F. So what is the points for D, E, and F? I'm going to divide by 2. So negative 6 divided by 2 is a negative 3. 4 divided by 2 is 2. Point E, 2 divided by 2 is 1. A negative 3 divided by 2 is a negative 3/2, or a negative 1.5. F, I take my image and I divide by the scale factor. 4 divided by 2 is 2. 6 divided by 2 is 3. So if I have the preimage, I'm going to multiply by the scale factor to get to my image. If I have my image, I'm going to divide by the scale factor to get to my preimage. I hope I said that right. Let me say it one more time. If I have the preimage, I multiply by the scale factor to get to my image. If I have the image, I'm going to divide by the scale factor to get to my preimage. Notice how the scale factor is 2, so my image should be twice as big. So this is half of this, or my image is twice as big as my preimage. Hopefully that made sense. Let me know if you have questions when you get to class tomorrow.